Alright, so we are on the home stretch for our area chapter. And we've got two more sections to go. The second to last one deals with circles and sectors. So we've dealt with polygons and looking at those. So now we're going to be looking at areas of circles and areas of sectors of circles and area of segments of circles. So that's what we're kind of talking about in this section. So the first thing is the area of a circle, which hopefully everybody remembers because you probably have had this drilled into your brain since you were, I don't know, 3rd grade, 4th grade, 5th grade, 6th grade, I don't know. But you've probably seen this many, many, many times before. So given a circle, what you need is you need to know what the radius of that circle is to be able to find the area of it. And so the area of a circle is pi r squared. So if we look at this example with this circle with the diameter of 48, we know it's a diameter because it's a chord that goes to the center. Yes, it is. And so what we have to do now is that we have to find what the radius would be. Well, the radius would be half of that. Half of 48 is 24. So when we plug it into the equation, we're going to have pi times 24 squared. Okay, now there's two different ways that this answer can go about. One is to keep it in terms of pi, which is how it's written right now on this image. 576 pi meters squared. If they say keep it in exact form or keep it in terms of pi, you're going to keep it like this. Okay, you're not going to multiply your number by pi or by 3.14 or 22 over 7, all those ridiculous simplifyings of pi. Pi is pi, and so you keep it like that. Okay. Now, if they want you to estimate what it is and round to the nearest hundredth or tenth or whatever, then you can multiply pi into it. I would recommend using the pi button on your calculators. All your calculators have a pi button. Use that one. It's more exact. But if it says in terms of pi, you've got to make sure pi is in your answer, or you've got to make sure it reduces out. Okay, so let's say we have this delicious pizza. And so what we're going to do now is that we want to know how much more pizza is in a 14-inch diameter pizza than in a 12-inch diameter pizza. So to find this, we're going to need to find what the area of the two pizzas are. And so the area of the 14-inch diameter pizza, we'd have to find what the radius of it would be, which would be 7. So we would get 7 squared times pi. And then that would be for the 14. And then for the 12, we would go half of 12 is 6. 6 squared times pi. So to find how much more, we would just subtract these two. And so as you see, we have the areas, 49 pi and 36. Subtract gets us 13 pi, which if we want that in exact form, we would say that it's about 13 pi inches squared more pizza. But since, most people are like, I don't know how much of that is. Well, and then we can change that. And when we change it and we multiply about pi into it, we get about 40.84 inches squared, or square inches more pizza in a 2-inch more diameter pizza. Okay. So as you see, it seems like a lot, 40, which is about a 8 by 5 inch pizza more, approximately. So there you go. So if they want to know how much more one is, just find the area of the two and then subtract. Pretty simple. All right, sector. The sector of a circle is the slice. So, the pizza slice or the pie slice of it. Okay. And the formula for that, which is right here when I'm talking about the area of ABC, this purple piece, the area of it is equal to the measure of the arc. Okay, so the arc all over 360 times pi r squared. Pi r squared is the area of a circle. So basically what we're doing is we're finding, okay, what fraction of the circle is it, which is the angle, the central angle, divided by 360 times the area of the circle. Okay. So if we look here, we look at this, we've got this pumpkin pie, delicious pumpkin pie. Let's say each side is about 5 inches. Okay, so each side is about 5 inches, and the slice is about 30 degrees. So if we plug it into our formula, we're going to have 30 over 360, because that's the central angle, which is also the arc measure. and then we're going to multiply that by pi times 5 squared. Okay, and that's going to tell us basically the top area of this piece of pie. Okay, and so we find that it's about 6.545 inches squared, or 25 over 12 pi of pi, pumpkin pie. 25 over 12 pi of pi. Yeah. Okay, pi, pi. This is pi. This is pie. Foot. So anyway, that's first sector. Okay, so you take whatever the angle is divided by 360 and multiply it by the area. Sector of a circle. Now, the segment of a circle. The segment of a circle is if you take a sector and then you draw a line connecting the two endpoints. Okay, the 2 points on this circle. You create this like little slice. Okay, and this little slice is the segment, which is what we want to find, And so what we're going to do is that we use this really, really, really long and crazy formula. 1/2 times the measure of the arc times pi over 180 minus sine, make sure you're in degrees, sine of the measure of the arc times r squared. Okay, so this is the whole thing. Don't worry, you don't have to memorize it, but you're going to have to know of it and know how to use it. So the measure of AB is the central angle / arc again, and then the radius. So for this example, our measure, this 80 would go here and here, and then 2 would go there. So when we plug it in, the first thing I'm doing here is that I'm doing the part inside the parenthesis, so it'd be 80 central angle times pi over 180 minus sine of 80, which gets us, that went in there, and then it's 1/2 times 4 pi over 9 minus 0.9848 times basically 4. And this you will not have to keep in terms of pi, you can just multiply through, and we get about less than a square inch of area on this circle. It's about 0.8229 square inches. Okay, so that's for the segment. Okay. All right, so looking at this one, when we set up this one, it would be 1/2 parenthesis 135 times pi over 180 close parenthesis minus sine of 135 close parenthesis of 16 squared. And then from here you do the part on the inside, and then you do everything on the outside, and then multiply it through. And you see we get about 211. So a lot of this is just plugging into the equation. Okay, and then just brute force finding. All right, so find the area of this sector. So again, this is the sector, not the segment. So the sector here, remember area of a sector. Let's say the radius is 10 in this case. So the sector is 165 all over 360. Okay, remember the central angle divided by 360 multiplied by the area of the circle, 10 squared pi. And then from here we would multiply the rest of the way through. And we get about 45.83 repeating pi units squared. Don't forget your units. Remember, it's units squared. So that would be the area of this circle, of this sector. Remember, the sector is the whole piece. The segment is just a small piece. All right, your IRAT, find the area of the segment and the sector of this circle. The central angle is 120, and the radius is 20 inches. Okay, so find both the segment and the sector. Okay, all right.